This is section 3.11 on the hyperbolic functions. And the homework is 1 to 17 odd, 30 to 35 all, and 38. Okay, so let's look at the hyperbolic functions. So definitions on page 259. Notice you have the 6 trig functions with an h at the end. H stands for hyperbolic. So technically, you're supposed to say hyperbolic sine, hyperbolic cosine, hyperbolic tangent, and so on. It's kind of hard to keep saying that. Okay, I will pronounce this as cinch, cinch x, cosh x. I don't really know how to say that. Tan, hyperbolic tangent of x. And then hyperbolic cosecant, secant, and cotangent. Okay, here's a definition of hyperbolic sine. E to the x minus e to the negative x over 2. Hyperbolic cosine, cosh, is the same thing except there's a plus, e to the x plus e to the negative over 2. Okay, the others are just piggybacking off where they were in trig. So hyperbolic tangent is cinch divided by cosh. So if you take this divided by this, the 2's cancel out. Okay, and so you have hyperbolic tangent. Okay, hyperbolic cotangent looks like cosh is cosh over cinch. And these two are just reciprocals of these two, just like they were in trig. Okay, so that means hyperbolic cosecant is 2 divided by e to the x minus e to the negative x. Hyperbolic secant is 2 divided by e to the x plus e to the negative x. Okay, you can put all these on your cheat sheet, your formula sheet. Don't worry about the graphs. You don't have to worry about the graphs of what these things look like. Okay, they're there, but don't worry about it. Okay. There are identities on page 260. I would say don't even put any of them down. You're not responsible for them. You don't have to memorize them, but you might have to prove some of them. So I think one of the homework problems, you have to prove this, or maybe this, and so on. So it looks sort of like some of the trig ones. Some of them look like them, some of them don't. And the hyperbolic derivatives. The only 3 I'm going to have you know are these. Okay, derivative cinch is cosh. Derivative cosh is cinch. They are derivatives of each other. It's pretty easy to prove. I'll go over a proof of one of them. Okay, that looks like trig, but remember for the derivative, the regular cosine is negative sine, but for derivative cosh, it's cinch. And that kind of looks like trig. Derivative of tangent is secant squared. So derivative hyperbolic tangent is hyperbolic secant squared. Okay, you're not responsible for these. They're correct. There's nothing wrong with them, but we don't use them that much. So I would say don't even worry about these 3. Okay. And the rest of this section, there's a lot of other identities, okay, but you're not responsible for any of those either. So don't worry about that, or a bunch of other stuff. So whatever else you see, don't worry about it. Okay, so here we go. Page what? 264. Okay, so those problems. We have proving some identities, just like in trig. Some more. Let's see, we don't have to do any of these, but we do have to do these. 30, 31, 32. We have to go up to what? 38. And here we are. Okay. Okay, 1a, cinch of 0. So by definition, e to the 0 minus e to the negative 0 divided by 2. That's 1 minus 1 divided by 2. 0 divided by 2. So the final answer is just 0. No big deal. Okay, b, cosh 0 is e to the 0 plus e to the negative 0 divided by 2. That's 1 plus 1 over 2. 2 over 2, 1. Okay, so no big deal. Side note, sine of 0 is also 0. And cosine of 0 is also 1. So that doesn't work for too many other angles, but at least for 0, sine and cinch are the same. Cos and cosh are the same. Okay, 3a, cosh of ln 5. So use the definition, e to the ln 5 plus e to the negative ln 5 divided by 2. Here I can cancel the e and the ln. Here you can't because of the minus. The trick is to put the minus 1 up here. So there's a negative 1 in front. Make it sneak up to there. So it looks like e to the ln 5 plus e to the ln 5 to the negative 1 over 2. Now you can cross off the e and the ln. So it's 5 plus 5 to the negative 1 over 2. 5 to the negative 1 is 1/5. And then multiply top and bottom by 5. So 25 plus 1 over 10, 26 over 10. Final answer is 13 over 5. Okay, then prove an identity. Cosh x plus sinh x, show that it's equal to e to the x. Well, you just do it. Cosh is e to the x plus e to the negative x over 2. Sinh is e to the x minus e to the x over 2. Add them up. These drop out. I have 2 e to the x divided by 2, which is e to the x. So that's the end of the proof. We're finished with that. Okay, 11 is much more work. It says sinh of x plus y is sinh x cosh y plus cosh x sinh y. That kind of looks like something you had in trig, right? In trig, you had sine of x plus y was sine x cosine y plus cos x sine y. So something similar happens here. Okay, I'm drawing a line here. It's an impenetrable barrier for proofs, meaning you can't cross these two until they're exactly equal. So for instance, you're not allowed to multiply the same thing on both sides. You can't take the square root of both things on both sides, right? You can't take the ln of both sides. You just work on this independently, work on this, and hopefully you get in a match. Okay, so the way to work this out is just use the definition. Sinh of x plus y is e to the x plus y minus e to the negative parentheses x plus y all over 2. This is negative x minus y. Okay, and I distribute it to make it look like e to the x, e to the y. That's the same thing as that. Minus e to the negative x, e to the negative y. That's the same thing as that. All over 2. Okay, so that's as good as I'm going to get with that. By the way, you might be a little bit uncomfortable with doing this. Well, in your algebra, you probably went from here to here, right? E to the x times e to the y. You would say, oh yeah, I add them, e to the x plus y. But you can go backwards too. You may not have done that much. But if you can go this way, you can certainly go this way. Okay, this one's more work. Sinh x, by definition, e to the x minus e to the negative x over 2. Cosh y, e to the y plus e to the negative y over 2. Plus cosh x, e to the x plus e to the negative x over 2. Sinh y, e to the y minus e to the negative y all over 2. Okay, so you got a lot of multiplication going on. Okay, the denominator is 4, right? 2 times 2 is 4. 2 times 2 is 4. Foil this out, foil this out. So this is e to the x, e to the y, plus e to the x, e to the negative y, minus e to the negative x, e to the y, minus e to the negative x, e to the negative y. Okay, so that's done. Plus, throw this out. E to the x, e to the y, minus e to the x, e to the negative y, plus e to the negative x, e to the y, minus e to the negative x, e to the negative y. So there's 1, 2, 3, 4, 5, 6, 7, 8 terms, all divided by 4. Okay, then these two cancel out. These two cancel out. I've got 2 of these. I've got 2 of these. Factor out the 2. Cancel the 2 with the 4. E to the x, e to the y, minus e to the negative x, e to the negative y, all over 2. And that actually is the same as the left-hand side. So that proves this identity. Okay, 17. Hyperbolic tangent of ln x is x squared minus 1 over x squared plus 1. Well, hyperbolic tangent is sinh divided by cosh. So sinh ln x, e to the ln x minus e to the negative ln x all over 2. Cosh, e to the ln x plus e to the negative ln x all over 2. The 2's drop out. Just like the other problem, that negative 1 can climb up, that negative 1 can climb up. So I have e to the ln x minus e to the ln x and negative 1 over exact same thing, except we have a plus. These cancel out, giving me x. These cancel out, giving me x at a negative 1, 1 over x. Multiply top and bottom by x. There we go, x squared minus 1 over x squared plus 1. Okay. And that's that. Okay, now some derivatives. Number 30. E to the x cosh x looks like the product rule. So first times derivative of the second, e to the x times cosh x derivative is sinh x, plus second function cosh x times derivative of the first, e to the x. And just factor out the e to the x. So final answer is e to the x times sinh x plus cosh x. 32, g of x is sinh squared. That's like sinh squared, outside function is squaring. So I go 2 sinh x, then by the chain rule times the derivative of the inside function, derivative of sinh x, cosh x. Okay, 34, what's the derivative of ln sinh t? To differentiate ln, you go 1 over, right? So 1 over sinh t times the derivative of sinh t, which is cos t. So I have cos over sinh, so hyperbolic cotangent or cos t, final answer. Okay, 38, what's the derivative of 1 plus sinh t over 1 minus sinh t? So quotient root. So bottom times derivative of top, derivative of 1 is 0, derivative of sinh is cos. Minus, temporarily it's a minus, I know it looks like a plus, but pretend minus, top times derivative of the bottom, derivative of 1 minus sinh t is negative cos t, so there's a double negative, that's why I made them positive. Okay, then just a little bit of touch up. Cos t distribute minus sinh t cos t distribute plus cos t plus sinh t cos t. These two cancel out. I got 2 of these, so best final answer is 2 cos t over 1 minus sinh t quantity squared. Okay, 31, f of x is hyperbolic tangent of square root of x. Remember, that's like x to the half. So derivative of hyperbolic tangent is hyperbolic secant squared of radical x. Then by the chain roots times the derivative of radical x, which is 1/2 x and negative 1/2. Bring the 2 down, bring the radical down. So final answer is hyperbolic secant squared of radical x over 2 radical x. And in case you're wondering, no, you cannot cancel these out. The square root of x is tied together with this, so you can't just cancel them out. Okay, going back to 15, prove the identity. Cinch of 2x is 2 sinh x cos x. That kind of looks like something in trig. Sine of 2x is 2 sin x cos x. So I just use the definition. Cinch of 2x is e to the 2x minus e to the negative 2x over 2. Nothing else to do. On this side, 2 sinh x is e to the x minus e to the negative x over 2. These can cancel out. Cos x is e to the x plus e to the negative x all over 2. So the denominator is 2. That's the difference of squares. That's a minus b, a plus b. So I square e to the x, e to 2x, minus the square of e to negative x is e to negative 2x. And there they are, they match. Okay, then one other supplemental problem. Show that the derivative of sinh is cos. Okay, and I might ask you something on the data in the test. You should know how to do that. So derivative of sinh means derivative of e to the x minus e to the negative x over 2. This is not a problem in the book. I'm just proving this, and you should know how to do it also. So take out the half as a coefficient. Derivative of e to the x is e to the x. Derivative of, well, I'm sorry. Yeah, I'm differentiating this. So take out the half. Derivative of e to the x is itself. Derivative of negative e to negative x is positive e to negative x. And this can be rewritten as e to the x plus e to negative x over 2. And that is the definition of cos. And very much likewise, if you take the derivative of cos, it's very much like that. And so it ends up being sinh. Okay. (3.1135) give the derivative of sinh ln t. So derivative of sinh of whatever is cos whatever, cos ln t, times the derivative of ln t, which is 1 over t. So cos ln t over t, final answer. Okay, then one more identity. Prove that the sinh of negative x is negative the sinh of x. That shows that sinh is an odd function. By the way, sine is also odd. Sine of negative x is negative sine x. Okay, so you just do it. Sinh of negative x is e to the negative x minus e to the negative x over 2. That comes out to be e to the negative x minus e to the x over 2. Okay, what's on this side? The opposite of sinh. So negative e to the x minus e to the negative x all over 2. Well, I can take the opposite of this. You just turn them around. So it gives me e to the negative x minus e to the x over 2. And you can see that they are indeed equal. All right, so that is section 3.11.